So in this video we're going to again find the intercepts of a linear function in slope-intercept form and use them to graph the equation, but this time we're going to do it in the case where the intercepts are going to be irrational numbers. And we're going to do this just because it seems like students sometimes get the idea that things always need to work out nicely because that's what happens in the homework. And I'm going to make sure that your homework doesn't work out nicely at least a couple times. So here I have a linear function in slope-intercept form. It has the form mx plus b. So in this case the m is equal to pi times the square root of 2. That's just a number, an irrational number. And the b is equal to pi. So it's still a linear function in slope-intercept form. It just doesn't have nice integer or rational number coefficients. But the concept of graphing it by finding the intercepts is the same. We know how to find the y-intercept because we've done this in the previous two videos. The y-intercept happens when the input or x value is 0. So we just need to calculate f of 0, the output of the function when the input is 0, to get the y-intercept. And I can do that. I can say, hey, input 0 into the function, which means take the function and everywhere I see x, replace it with 0. So I get pi times the square root of 2 times 0 plus pi. And stuff times 0 is just 0, and 0 plus pi is just pi, which means that my y-intercept is input 0, output pi. We could also start to recognize that this value for b always turns out to be the y or f of x coordinate of the y-intercept. So we could have just looked at the equation and actually said, hey, there's my y-intercept value. My location is going to be at 0 and pi. For my x-intercept, everything will be the same as it was before. Intercept. We know that the x-intercept is going to happen. We don't know what the x value is going to be, but we know that f of x is going to have to equal 0. The output to the function needs to be 0 when the x-intercept happens. So we can say the same thing that we've been doing before. We can say, hey, 0 needs to equal f of x, but f of x is just this expression right here, pi square root of 2 times x plus pi. And now I just have a linear equation in one variable, and I solve for that variable. So I'm going to subtract pi from both sides, which is going to leave me with pi times the square root of 2 times x. And then I'm going to divide both sides by pi times the square root of 2. And negative pi divided by pi is just going to equal negative 1. So I get negative 1 over the square root of 2 is equal to x. So what I discover is that when I input negative 1 over the square root of 2, the output of the function is going to be 0. I could rationalize this denominator if I wanted to. I don't think that it's necessary. I have a negative number that I need to graph here to get my, whoops, I got that all, oh no, we're good. For a minute my brain glitched and I thought I wrote it wrong. Input negative 1 over square root of 2, output 0. So here's my x-intercept and here's my y-intercept. So I'm going to just draw in my axes like we did in the previous two videos. Arrows on the axes because they're number lines. They go infinitely far in either direction. Pi, input 0, output pi. Pi is a number that's about 3. So we know this number right here is about 3. And it turns out that negative 1 divided by the square root of 2 is going to be about negative 0.7. So it's a number that's a little bit less than 1. I mean, the idea is that the square root of 2 is bigger than 1, but it's not a lot bigger than 1. So I have negative 1 divided by a number that's just a hair bigger than 1. So I know that this number right here has to be a little bit less than 1. So I really have something that's going to be kind of an up 3 kind of thing, because pi is about 3, and then over on this axis in the negative direction about 1 over this way, just as a rough picture. So just draw in your linear function that fits those specs, put your arrows on it, and then label in your intercepts. This intercept here happens when x is 0. My output is pi. And this intercept right here happened when x was negative 1 over the square root of 2. And the output to the function was 0. I'm not doing decimal approximations for these. I don't need tick marks. You just get a ballpark picture and make sure you label your intercepts. And again, drawing the line first and labeling the intercepts afterwards frees you up from having to worry about tick marks and how far after 3 do I have to put the pi, that type of thing. And now just make sure we label our axes. This is the f of x or the y-axis, and this is the x-axis. And there I have graphed an equation that had irrational numbers for their intercepts.